I am Anil Kumar. Welcome to my series on calculus. In exam review, here is a question on chain rule. The question is, find dy dx when x equals to half, f prime 1 over 8 is 16, f prime at half is 1 over 3, f of half is minus 2 for the following functions. 5a. Y equals to 5x cube, b is y equals to f of x whole cube, and c is y equals to 1 plus f of x whole square. You can always pause the video, answer the question, and then look into my suggestions. So let's recall the rule itself. So we are looking at the function, which is a composite function. So if we have f of g of x, in that case, the derivative of this particular function, d dx of a composite function, is equal to f of g of x times the derivative of inside function. Correct? So that is the rule. So we'll apply this rule to find the solution. So let's begin with the very first one, which is given to us as y equals to f of x cube. Right? So inside function, g of x is x cube for us. So what is the derivative? The derivative of this function will be derivative of f of x cube times, we have to find the derivative of inside function, which is x cube, right? So you could write this as, you could write d dx of this, right? So that gives you f prime as f of x cube times the derivative of x cube is 3x squared, right? Now we need to find this particular value for x equals to half. So let's substitute x equals to half and find the value. So what we get here is y prime at f dash of half cube times 3 times half square, right? Let me write like this. Okay, so that is f prime of 1 over 8 times 3 over 4, or 3 times 1 over 4. Now f prime of 1 over 8 is given to us, which is the value 16, right? That is the value given to us. We'll use this particular value. So we can write this as 16, and then we have times 3 times 1 over 4. And you can always simplify this. 4 goes 3 times, and what you get here is 3 times 3, which is 9. So that becomes the solution, right? So our answer here is 9. So that is part A. Now let's take up part B now. So part B is given to us as y equals to f of x whole cube, right? So we'll apply the combination of power and the chain rule. Y dash will be y prime as 3 times f of x whole square times the derivative of inside function, which is f prime x. Correct? Now again, we have to figure out what is this derivative at x equals to half, right? So at x equals to half, we can substitute our values as we did earlier and calculate. So we have y prime at x equals to half as equal to 3 times f of half whole square times f prime half. So that is equal to, now we're given this value of f of half, which is given to us as minus 2. And f prime half is given to us as 1 over 3. We're going to substitute these values. So within brackets, f of half, which is minus 2 whole square, times the derivative at half is 1 over 3. So that gives you 3 and 3 cancel, and you're left with minus 2 square, which is indeed 4. So in this case, the answer is 4. Perfect. Now let's take part C. Part C is f y equals to 1 plus f of x whole square, right? That is it. So when you find the derivative, you'll first apply the power rule. So we get 2 times 1 plus f of x, correct? Times the derivative of inside function. So we can write the dx of inside function, which is 1 plus f of x. So we get the derivative as 2 times 1 plus f of x. Derivative of 1 is 0 plus, we can write this as f dash x. Okay. So now we can substitute the value and find the answer. We are interested in finding at x equals to 2, right? So let's substitute at x equals to 2, what happens? So we have y prime at x equals to 2 equals to 2 times, within brackets, 1 plus, not 2 but half, I'm sorry. X equals to half, not 2. So f of half plus times f prime of half, correct? So that is what we are interested in finding. So we get the result as equal to 2 times 1 plus f of half is given to us as f of half is minus 2, and f prime half is given to us as half. So that is minus 2 times f prime half is 1 over 3. So we get 2 times 1 minus 2. 1 minus 2 will be minus 1. So we write this as minus 2, right? Times 1 over 3. So we get the answer as minus 2 over 3. Clear? So that is how we are going to solve this particular question, right? So we have done all the 3 parts, and I hope you understand how to do function or functions derivative with this particular example. Feel free to write your comment, share your views, and if you like and subscribe to it, that'll be great. Thanks for your time and all the best.